Today I'll be testing the Dr. Puri KF94 mask. I got these from a website that I'll link below. They do offer an English language package that I received. Seems legitimate. They do have this lot number as well, lot 3060. And this is one of the masks. I did wear this mask for about maybe 5 or 6 hours already, just to get a good feel for how well in terms of pressure drops. I'm testing it at, some of the electrostatic media can lose a little bit of performance efficiency, so maybe we'll see a slight difference there. I did put a test fitting on it so we can do the fit test. I did put a little bit of RTV 162, which is an electronics grade RTV, on this interface back here during the installation process to help prevent any leaks and get a real accurate one. We'll then also compare that to a Moldex N100 mask that I have just to verify our setup. In terms of aerosol generation, I'm using ambient aerosol. I'm using my bathroom because it's one of the smallest rooms I have in my house, and sealed at least. And I'm going to be using the TSI 8026. This is usually used with a port account. I put 200 milligrams of salt in 80 milliliters of liquid, which is usually the recommend. They usually recommend one tablet, which is 100 milligrams. So we'll see what that is. I do have a Sensorian, what's the number? SPS. I'll have to put a link in the description below. I think it's SPS 50 or 30. It's a optical particle counter, and will give us some good information about size distribution. I think one of the challenges when we do these tests, so we'll talk a little bit what are the limitations of my tests. One is I'm using ambient aerosol, so we're going to have some stuff that's really small. This particular counter, a TSI 3025A, could go down to 2.5 nanometers, as well up to a micron or so, which really just comes down to sampling loss. So we'll be trying to generate some small aerosols, somewhere around, hopefully, ideally I'd like to generate around 100 nanometer to 300 nanometer. I'm not sure exactly what I'm going to be generating. I do need some more equipment to measure the size distribution of the aerosol, but we'll use this as just a general test. We can compare that to our N100 to get a relative comparison of this in sort of like a general ambient condition. So we'll run that. We'll bring up our concentration to about 20,000 particles per cc, install the mask, do a couple fit checks, and then compare that to the N100 as well. So to start the test, what I am going to do is turn on the generator. So it might be difficult to see, but there's a little bit of a stream. It's basically a pneumatic atomizer, and it's atomizing this salt and water mixture. That water will evaporate off, leaving behind a salt particle, and then we're going to measure that with our counter here. And so we'll let this stabilize to about 20,000 particles per cc. There will be some coincidence happening on our TSI CPC, so it's going to start missing some of the counts. So if anything, this will underestimate the actual true concentration, meaning our fit test will actually be better than this value. Why am I going that high? Well, the reason that I want to go that high is that my background concentration from just ambient air is about 5,000 particles per cc, and typically for ambient aerosols in an urban environment, that's going to be like 100 nanometers, peak mode. So what we're trying to do is dilute that down a little bit with our test aerosol. Unfortunately, it's kind of an unknown size, so there still needs a little bit of work on this apparatus, but the test apparatus that will be, or the measurement system we'll be using is a TSI 3025A. I am using some Tigon line, so we'll have some particle loss within the line, but the particle loss is consistent whether you're sampling the raw, the ambient conditions or in mask. So if you have, example, let's say 10% loss of 10 nanometer particles across this sampling line, then that's the same 10 nanometer percentage loss that we would see with ambient air. So it kind of cancels each other out. I am using a TSI, basically it's just a water catch in here just to make sure that doesn't get into the CPC. And then just some pneumatic connections to get that across there. So I'll let this come up to about 20,000 particles per cc, and then we'll start the test and we'll do some comparison. Concentration a little bit there. Left it on for a little too long. I'm not sure why my video camera mirrors this. So it's 3.1 and 10 to the 4, so 30,000 particles per cc. Now some of you guys might ask, well, how is this test different than a N95 fit test, which would use a port account and an N95 companion? So the difference between what I'm going to do here and a traditional fit test is that a fit test, the media is already qualified, or the face mask material is already qualified at N95 or greater. And it's typically measured across between 0.1 and 0.3 micron. I'll have to double check the exact NIOSH specs, or with the spec for an N95, I have to look it up. I can't remember off the top of my head. But the media is already qualified. So what they're trying to do is measure the leakage rate that's coming past your face. And the way to do that is to generate an aerosol and then size select it such that it's much smaller than that 100 nanometer. So if we look at a typical aerosol or sorry, a typical filtration curve, there's this local minima between 0.1 and 0.3 micron due to its low diffusion and low inertia of the particles. And so if we go even smaller, so let's say we size selected for a 40 nanometer particle, we'll find that the N95 media filters at really high efficiencies there. And so an N95 companion has a radial DMA, and they're size selecting for a much smaller, I'm not sure exactly what size they use, but they size select for a much smaller aerosol, so that for that particle size, the face mask works at nearly 100% filtration efficiency. So that way, if you measure any particles inside the face mask, you know they came through leakage past your face. And so that's a fit count, because they already know that the N95 has a 5% leak rate. In the case of this experiment, what I'm going to be measuring is the combined filtration efficiency of the mask, as well as the leakage that's going to happen past my face. So this is really going to be like a real-world example of this sort of quasi-generated aerosol, which I'm not sure exactly the size range. I'll have to get some more instrumentation to measure that. The SPS 30 is showing peak count mode of about 0.95 micron. That only measures down to 0.3 micron. So I think we have a pretty good aerosol. It's only counting about 5,000 particles per cc. This is counting about 28,000 particles per cc. So I'm guessing that the mode is much below that. So hopefully we have a lot of 100 nanometer particles. This will be a really good test to see, just in general, how do these work with the kind of quasi real world aerosol challenge. So let's give it a chance. I'm going to take advantage of the mirror located in my bathroom to help shoot this. Again, this isn't the highest grade video quality, but we'll just try to show what we're doing. So right now we're with the mask connected, but obviously not attached to my face. We're getting about 2.85. So for the Dr. Pury KF94, so we're getting upstream concentration of 2.85 times 10 to the 4th particles per cc. Okay, so we'll go ahead and install the mask. This is going to be testing filtration efficiency of the mask and its fit. So to start with, I'm going to install the mask, and I'm going to use the included mask loop because I really want it tight to my face, and then we'll test ear loop only and see how we perform. Now we're already down to about 1,000 particles per cc. This long continuous press. I'm going to squat down a little bit. The only thing I've noticed with my setup is that the tubing is pulling on the mask a little bit. Yeah, so you can kind of see as the count comes down here. I do have a long section of tubing. The sample's on the high flow rate right now, which means that, actually let's check on that. Let's see. We are at the high flow rate. So, we're looking at about just a little under 1,000. Goes down to about 500 when I breathe in. Still coming down. So let's call it about 500 particles per cc. Getting 5.5 E times 10 to the 2 particles per cc. So that means we got 550 particles per cc mass. Divide that by 28,500 particles per cc. So that's going to give us filtration efficiency. If I switch apps, unfortunately it changes, and I lost the video there. So I just finished the math. So we had a measured value of about 550 particles per cc with an incoming challenge aerosol of 2,500 or 28,500, excuse me, which gives us a fractional value of about 1.9% leakage. So that means that this is effectively as installed on my face with the challenge aerosol used. This is a 98.1% efficient mask. Now we did see some filtration variation as I breathe in and out. And I think that's just because as I talk, I'm moving my mouth and it's causing leakage. So now let's test a different fit mode. So right now I'm going to switch and I'm going to go to just using the mask. With the standard ear loops, it's far too loose for my preference. So I'm going to just do a little trick where I tie a little knot into it here. And that lets me shorten these ear loops a little bit. So I'll try that. And then after we're done with this, we'll do the N100 mask that I have here just to validate the setup to prove that it is effective at measuring really high rates. Okay, so I think that should be good. Okay, so I'm going to shorten the ear loop. So I'm just going to go to a standard ear loop. Now, this is going to pull a lot less against my face, so I'm going to probably see a lot more leakage, but this is a good indication about mask fit and its impact on the filtration efficiency. Again, the tubing does pull slightly on the mask. I should probably try to come up with a better attachment. Maybe I should attach it to my... I need to come up with a solution to attach it to my shirt. Okay, here we go. Alright, so just ear loop style. You can see there's a lot of leakage. So I'm only getting about 2,000 particles per cc. So here we're only getting about maybe 93% efficiency. And again, that difference is due to leaking in the face mask because it's not tight against my face. So it's coming down a little bit there. I think it really depends on exactly how I'm breathing here. So if I'm standing here, you know, yeah, so there's definitely a lot of fit issues here with these kind of masks, and that's kind of expected, and it's also a byproduct of my technique here. If I hold this tubing myself, I think that helps a lot. I think I should have done it right in the middle of the mouth instead of the side. Next time I'll puncture it right in the center, not do the side. I thought it would be better on the side, but I don't think so. Okay, so almost double. It depends exactly where I'm breathing at and where you measure it. If I just take a slow breath in here. You can see it spikes. I'll take a really deep, fast breath, and we'll see how bad it spikes. So let's just say it's about 1,500 particles per cc for right now. So let's check the challenge value. Could have changed slightly since we started this test, so I'm just going to set the mask here again. Okay, so getting about 2,800 to, well, so this, again, this isn't a perfect test. So I mean, you can do much better quality data if we did a lot of average. I just want to do some quick checks to show people the setup and the apparatus, and maybe I'll just publish papers in the future. So let's just say it's about 2.96 times 10 to the fourth. We were seeing, I'm going to say approximately 1,500 particles per cc with ear loops. Oops. Poor handwriting, will always get you. All right, and then we'll do the math afterwards, and I'll calculate what that is. Just because I don't have a calculator right with me right now. Okay, so let's do the N100 mask using the same setup. So this is a Moldex. Let's see if I can get the name off of it. A 2730 N100, medium and large N100 face mask. So we'll do the same experiment here as I did with the Dr. Pury. So I'm getting about 2.55 times 10 to the fourth incoming aerosol. So I'll set that down. So the N100 is 2.55 times 10 to the fourth. Okay, we'll go ahead and start. So this is N100. It's got the two straps. Let's check a look at what our count is now. Alright, so we're getting and you're seeing the particle light flicker, and that's because there's basically no counts at that moment. Okay, so we're getting about, it's a little hard to get a little bit of variation there, but I'm going to say on average, about 11 particles per cc if I just breathe in a nice consistent. So 11 particles per cc. We'll do a deep breath and see how we stack there. You get a little bit of variation just because I have some leakage when I talk and my face moves, and this mask does not fit me perfectly. It would not be a good example, but you can see with an N90, P100, we're already almost one magnitude lower. So let's call it about 144 particles per cc. Or sorry, yeah. So I got 1.44 times 10 to the 2. So that's 144 particles per cc in a deep breath scenario. So let's just average it out and say, look, it's roughly around 100 particles per cc. So 100 particles out of 250,000. So sorry, 25,500 particles per cc. Let's calculate that. The final stats come on, and this is kind of just handwritten notes. So for the Dr. Pury, if you use the full mask clips, I had about a 1.9% leakage rate, or an effective filtration of 98.1%. If you go to ear loop only, that I kind of tightened up to feel comfortable, we got about 5.1% leakage, so a effective filtration efficiency of 94.9. Pretty good considering these should be rated at KF94, although that is specifically KF94 from the range of 0.1 to 0.3, I'm assuming, but I have to check. I'm not familiar with the KF94 standard. The N100 mask, we had a wide range depending on if we had a little bit of leakage, and that's really, we're going to be really sensitive to that. So if I used 100 particles per cc upstream concentration, and I assumed the 2.55 times 10 to the 4th particles per cc downstream concentration, upstream concentration, this is the in-mask concentration, that gives us about 0.3% leakage, or effective 99.6. So, I mean, what this is really doing is validating that the apparatus that I use is capable of resolving a pretty big wide range of filtration efficiencies for these masks. And I'm going to use it one more time because I have one other mask that I want to check out, which is the I can't remember what it is, Bhati mask. So we'll check that out. So here we are with the final stats for the Dr. Pury. All right, back in the bathroom to run another fit test. This time we're going to use the BOTN KF94. Again, I'll shoot the link about where I bought this online. It seems legit. There's a lot number AW92002. Why do I like this face mask over the Dr. Pury? We'll test to see how the filtration efficiency goes, but one of the things I really like is that they have kind of the front of the mask is a little stiff, and what makes that really nice is that it doesn't collapse down to your face when you're wearing it. So let's do some fit tests, see how it performs. There's one other nice feature is it has these adjustable ear straps, which I've kind of already adjusted for just doing the single ear test, and then we'll do the double ear loop test and see how the leakage is. All right, we got the mask hooked up, reading about, I'm going to let it stabilize here for a second, kind of come up with a rough average. Again, this isn't perfectly statistically accurate. I could take some real data, but we're just trying to do some rough fit checks to see how these masks perform to make sure that they're at least close to the rated value in a semi-real world trick. So I'm getting about 1.95, let's say, upstream concentration. So, or sorry, 1.95 times 10 to the 4, so almost 19,000 particles per cc. Okay. And now let's install the mask and see how it fits. Video editing, but I'll have to get better at it. Alright, so this time I put the puncture, or the port right in the front of the mask. I did a little trick where this comes with an adjustable ear loop, but I'm just basically flipping it in half. I have double ear loop power. I like this because if you need some better, you will see about how much leakage you have with this, but it's kind of nice is that I feel like it gives me a really good face seal. And remember, leakage is going to be one of the big factors in this type of mask. Okay, so we started with 19,000 or 1.95 times 10 to the 3rd, so let's see how this mask stacks up. I'm going to do the same kind of thing. We're going to breathe out. Breathe in. Breathe out. Breathe in. This is looking really good, actually. It's getting about 300 particles per cc. Seeing some really good, you see a little variation in this, and what you're seeing is that see how this is the flow monitor. This is a flow split CPC, so there's a flow split where they're monitoring the total flow, and this is a small flow that runs through a capillary, and they're monitoring that pressure. What's happening is when I breathe out, it's causing the flow to spike a little bit. The pump's having to slow down. So we're going to see a little bit of variation in my measurement because, I mean, maybe this isn't the perfect device to measure this, but at least give us a rough order of magnitude. So let's, what I'm going to do is I'm just going to breathe in a nice steady breath, and we'll see what that number goes to. Getting about 290 for my son there. All right, so it's hard to say exactly what the steady is, but let's call it about 350. Okay, so 350 particles per cc. Okay, so this is with the double ear loop. We'll now adjust to a single ear loop condition and see how that looks. The only thing I would say is that the ear straps are not super tight. So in this condition, I would say it's like pretty comfortable. I can feel that it's loose up against the top of my face, so it's not as great of a fit, but let's see how the filtration efficiency turns out. So we're going to assume that that upstream concentration hasn't changed too much. We'll just use this as a relative metric. So about 300 particles per cc there is 1,000, 700, 600. So I'm actually kind of surprised because it doesn't feel that tight against my face. It felt much tighter with the double ear loop. And we're getting more leakage there, but it's really not too bad. So I'm going to eyeball my estimate of what I think the middle is. I'm going to say it's about 600 particles per cc. We get a lot of variation there with my breath and also the sampling of the system. So we'll say single ear loop, about 600 particles per cc. And we'll calculate the filtration's efficiency with that. So in general, I think take a look at the numbers. So with the double ear loop test, our starting concentration was 19,500. I measured about 350 particles. Again, it depends exactly when you were measuring it. I saw some variation there, but if we use that kind of as like the average number, so we can calculate our filtration efficiency with leakage plus mask leakage plus the actual filtration efficiency. So we get about a leakage of about 1.8%, so effective filtration efficiency in mask of about 98.2. So again, it's better than the rated KF94. Again, the test that I'm using though isn't perfect. I'm not using an aerosol that's 0.1 to 0.2 micron. This is a polydispersed aerosol, so there could be a lot of variation. But I just want to give some real-world example tests here. So with the single ear loop, so I just use the single ear loop. It's a little looser to the face. You can see I get a little bit more leakage, about 600 particles per cc. It gives me an effective filtration, effective filtration of in mask at 3.1%, or 96.9% of particles were filtered out. Again, this is polydispersed aerosol. It's not perfect. We have a wide range of sizes that I'm testing. Some of these are going to fish. Some that this mask will effectively filter much better than others. But I like to just do this just to get a real world example. Are these junk? Are these real, or are these some bunk product? And I think in general, the results that I'm seeing seem legitimately good filtration efficiency. So I think these are real, and I think these can be an effective way to limit your exposure to COVID.